Lakehouse Monitoring is in GA, and what is it? It is an easy solution to profile, diagnose, and enforce quality directly on your Delta tables through the Databricks Lakehouse platform. And we will straight jump into the demo to show you how this actually works. Again, we've said it before, but you can find all of these demos in DB demos, and this is one of these as well. So what we have here is a couple of tables. So we have the products, the users, different transactions these users did to buy products. And then we have some kind of aggregated tables for monthly sales, top products, and top users. Clear?
Yeah.
Excellent. So a key thing that analysts would like to see in these tables is how many nulls we have per column they care about. And in this case, they want to see and understand how people buy from these stores. So what is their preferred payment method? So is it transfer, credit card, and etc. And they want to see how many nulls we have in this kind of feature. Now, this is something you can do one-off and check it, or you can build a monitor to help you identify those and track it in a more automatic way rather than manual and one-off. So this is what we're trying to do with this specific kind of example. So let's jump to the dataset. So the dataset looks like this. So we have the transaction dataset where we get all the details for each transaction. And this is the column we care about tracking at this point, which is the preferred payment method. And then let's go through how we can create a monitor. I'm going to show you how you can do it with the API now, but again, you can do it through the UI and the UC tables as we're going to show you later. The first thing to understand is that we have three different monitors. The first is a time series where we aggregate quality metrics on a time window, right? So we say, I want to calculate these metrics for the past month or for the previous day, and etc. The snapshot, where we calculate the metrics over the full table we have as of that point. And then the inference, which is we calculate drift and performance of models. Again, we'll link the dots here on how serving a model, writing inference tables to creating this inference monitor work.
And just to clarify here, the requirement that we have is just to have a Delta table, right? You don't need anything else to get started.
Exactly. Yes. So everything is tracked and created through the Delta table we are monitoring. So the monitor is relevant to a table. Okay, so what we need to do is import our libraries. And in this case, we are importing the monitor time series as well. And we will define this window, how many days before we are going to calculate this monitor metrics. And in this case, it's 1 day. The other thing you can do is slice your table and create monitors on this. So let's say that you have here different categories that you can create monitors for. For example, I want to create a monitor for only the toys. So slicing the table, filtering the table on only category equal toys, and then calculating all the drift and etc. metrics that we care about.
That's really interesting. Also, just one thing to point, correct me if I'm wrong, but I think when you enable a monitor on the table, it's going to automatically build a super nice dashboard for you, and you don't need to do anything. But what you're telling me now is that you can also add like custom metrics and just slice and dice as you want, right?
Exactly. So like by default, it's going to create a predefined dashboard, but then you can create your own business KPIs or business metrics that you can adjust or add into this dashboard. So the dashboard is kind of created for you, but you can go tweak and add anything you want, anything relevant to your business. Very good question. So here what we're doing is mainly we're saying this is the table name we are going to create the monitor from. And this is the column, the timestamp column. And we're just going to go and read. This is the table we're going to use. And this is something that it's that before we create the monitor, allow the CDC functionality on the table for cost optimization reasons.
Yeah, it's very important because that means you only process the newly added data, so the appended data to the table instead of like reprocessing the whole thing every time. So that's more efficient and it will definitely help you save on what you spend. So very
This
good.
is a very good
practice.
pointer. And then we go and literally we create a monitor by hitting the quality metrics. Quality monitors create, we pass the table, we pass the column, any granularities we want to calculate the monitors for. So in our case, we said 1 day, and then where we are going to write. And by that, we just wait here for the monitor to create. Nothing is really happening. And then we can go and display all the metrics created automatically from this operation. And in this case, we created the profile metrics and the drift metrics. And as you can see here, I printed here. And for each window, right? So we said the window is 1 day, and you can see it here from start to finish. It went and created a lot of different columns, statistical columns as well, and also like how many distinct counts of items we had in each column, zeros, percent of distinct values, and etc. And for the drift, we have again the same window of operation. We said 1 day. And then here you can see a little bit different columns. So the drift type, the average delta, again, and some common like percentage of this thing and percent of those zeros as well. Now, this is not an easy format to understand and utilize. So what we have done is automatically we take this and we create an aggregated dashboard for you that Lara said before. How does this look like? You go to dashboards, and then it looks like this. So this is the default dashboard that comes from a time series monitor. So you will see here that we have the last window that data was calculated for, when and from when and to when you want to start monitoring data, because different captures of data, as we saw, are happening behind the scenes. So you can change the dashboard and show a very specific slice of data. So you can adjust your monitor to this specific kind of duration. And then you can see how many rows you have over time. You can see nulls over time. And here you can see that for the preferred payment method, there were suddenly a lot of nulls. This is something we have to go and check why and how it was this created. Percentage of zeros. Again, we see that for the discount column, we have consistently kind of a big number is actually 0 in comparison to the other columns. This is something we have to understand our data if this is expected or not.
Yeah, and one thing that's also very interesting is that all of this, so if you click on the 3 dots for each visualization, you can access the underlying SQL query that powers it. And from there, you can, like for any SQL query in Databricks, you can just set up, like a SQL alert so that you can define a certain threshold. When this threshold is met, then send me, a notification. I think that's also very like something to be aware of in the dashboard.
So everything that we are seeing here on the graph behind the scenes, as Lara said, is connected to a query. So you can go adjust this query based on your needs, requirements, and any bespoke computation you can do. You can update it and put it into the dashboard. So it's completely kind of adjustable to your needs. Any questions here, Lara?
No, very clear.
Amazing. So let's go to the UI. So here we are in Unity Catalog. We are in a specific kind of table that we know. We have some data and we have some brand data in this case. And what we want to do is go and create a monitor for this specific table, because we saw before how we can use it with the API. Let's go now straight to the table and create a monitor. So we go to the quality tab and you can say get started. And here you can see the 3 different monitors that we discussed before. Before we implemented the time series monitor, and now you can do a snapshot again, as you said, on the whole table, or an inference monitor. So you click what you want to do. You select again your granularities and your timestamp column, and you do create. By hitting this create, it's going to capture all of these things and timestamp calculations we saw before, and also create the dashboard for you.
Amazing. One question though that I have is, so if you look at the profile tab, and you see if you click and you have those three options depending on the type of data that you analyze. I understand time series and snapshot, and for inference as well. But how does that relate with the inference tables that you can have, from a model serving endpoints? Are they separate features, or like how do they relate to each
Okay,
other?
very good question. So let's go to the model serving. So let me zoom out a little bit so that you can see. So here we are in the model serving endpoint. I'm in one model that I have created, and I'm actually already been serving. And you can do that to a new model or to a current model. So you go to your model and you do, so let's say it was like this, right? So we go to the model, you will say edit, inference table. So here you go to inference table and do enable inference tables, and you choose a specific catalog, schema, and prefix. So what this does, it goes and collects all the payloads sent to the model and everything from the model responding to the user. So all of these are tracked and written in this specific table you are creating. Okay. Now, having created this table, what you can do is go here in the catalog and say, hey, this table was created from a model serving endpoint, and it's actually capturing all my payload responses and requests. So I can come here and say, since it's a model and I'm monitoring a model, I want to create an inference monitoring so that I'm capturing the drift. So how did my model perform, or the model performance changed over time? Does this make sense?
Okay. Got it. So if I rephrase, basically, to make sure I understand, from the model serving endpoints, you can create inference table that's going to actually create the table with, like the input requests, etc., like all the information, the payload. And then once you have that table, you can go into that table. You have specified the catalog, schema, table name. So you go onto that. And from there, you can enable this monitor, which is essentially a dashboard. And here, by selecting inference, it just makes sure that it's a dashboard that is like particularly relevant for ML models monitoring. Okay,
and calculates drift metrics as well that before we didn't have. Excellent. So this is this. So the last thing to say is about some new features that are coming into the Lakehouse monitoring. And this has to do with actually data quality expectations. So we had data quality expectations for delta life tables, but now you can do it to any table. So to any delta table, you can apply it. And how does this look like?
It's on the roadmap though, but yeah.
Yes.
We can't do it right now.
Overpromised. So in private preview, you have aggregate expectations. Yeah. You can define specific expectations for any primary foreign keys and aggregate constraints. We can send notifications and get alerts when these expectations fail on the data table. And then we can have much better observability, because now for each table, we can have this symbol showing, this table is clear, perfect, all the expectations passed, where this table actually failed. So go and check it.
It's super useful, because if you're browsing tables, you're just doing some discovery, you want to check what your colleagues have done or whatever. It's one thing to go into a dashboard and check, how they're doing. But it's another to just quickly browse and see green everywhere or red everywhere. So this is a very good feature, and great to see that expectations are going to be extended from Delta Life tables to Delta.
And as a user trying to find a good table to use for my use case, if I see a table with red and failed expectations, probably I would go and raise concerns, right, on the quality of the data. So it's very good to push some data quality in across the organization.
Yeah.
And the last thing is that we're trying to make this alerting system a little bit more clever by adding some AI in it, so that we kind of send you only the alerts that you actually should check.
Yeah.